Welcome to the class on group technology. Group technology is a manufacturing philosophy in which similar parts are identified and grouped together to make advantage of the similarities in design and production. Here, similar parts are arranged into part families where each part family possesses similar design or manufacturing characteristics. Whenever you're going to implement group technology, there are two major tasks that a company faces. The first one is identifying the part families. Second one is rearranging the production machines into cells. For example, if a plant makes 10,000 different parts, reviewing all of the part drawings and grouping these parts into families is a difficult task and it consumes significant amount of time. Similarly, if you want to rearrange all the machines, then you are not going to produce during the changeover. It will affect the cost. Coming to the benefits of group technology, it promotes standardization of tooling, fixturing, and setups. Material handling is reduced because parts are moved within the machine cell rather than within the entire factory. Third, process planning and production scheduling are simplified. Setup times are reduced, resulting in lower manufacturing lead times. Coming to part family, it is a collection of parts that are similar either because of geometric shape and size or because of similar processing steps that are required in their manufacture. The parts within the family are different, but their similarities are close enough to merit their inclusion as member of a part family. You can look into the picture which shows that here these components are rotational parts requiring similar turning operations. Similarly, these are some of the part families which will be having either similar design attributes or manufacturing attributes which will make them or group them into a part family. So how you're going to group these components into a part family? So generally there are three methods involved. The first one is going to be the visual inspection. Second one is part classification coding. Third one is production flow analysis. In visual inspection, you are going to visualize the component and then you are going to group it accordingly. In production flow analysis, you will be making use of the routing sheet. So in this class, we are concerned about part classification and coding method. So here, similarities among parts are identified and these similarities are related in a coding system. So two categories of part similarities that can be distinguished are the design attributes, which will be concerned with part characteristics such as geometry, size, and material. Second is manufacturing attribute, which consider the sequence of processing steps required to make a part. So the reasons for using a classification and coding system is that the design retrieval is very easy, then automated process planning can be generated, and it will facilitate machine cell design using composite part concept. So in design retrieval, the designer will be able to retrieve a coding system which is existing for the particular part family. And for automated process planning, a part code for a new part can be used to search for process plan of existing parts with identical or similar codes. So a part coding system consists of a sequence of symbols that identify the part's design or manufacturing attribute. The symbols are usually alphanumeric, although most of the systems use only numbers. So you will be making use of three basic coding structures. The first one is the chain type structure. It is also known as polycode, in which the interpretation of each symbol in the sequence is always the same. It does not depend on the value of the preceding symbol. You can see here code value 1 will always say about the material. Similarly, code value 7 will indicate the test method which is used there. irrespective of the value of 6. Second is hierarchical structure. It is also known as monocode, in which the interpretation of each successive symbol depends on the value of the preceding symbols. Third is going to be the hybrid structure. So it is going to be a combination of hierarchical and chain type structure. So here I'll discuss a type of classification system which is called as a Opitz classification and coding system. So it is intended for machine parts and it uses the following digit codes. The first one is going to be the form code. It has got 5 numbers which is intended for design attributes. Second is going to be the supplementary code. It has 4 digits intended for manufacturing attributes. The third one is going to be the secondary code. It is going to be alphabets for production operation type and sequence. So here you can see the form code and the supplementary code explained. Here digit 1 is going to discuss about the part class, digit 2 about the main shape, digit 3 about the rotational machining aspect, digit 4 about the plane surface machining, digit 5 about the additional holes, teeth and forming required, and 6, 7, 8, 9 digits are going to be the supplementary code which will be describing about the dimension, the type of material, original shape of the raw material and the accuracy which is required there. So if you're going in detail about the rotational parts in the Opitz system, you can see that if my component is going to be a rotational part with L by D ratio lesser than equal to 0.5, then my first digit is going to be 0. Then this particular part will be a step part with thread. Then my digit 2 is going to be 2. Similarly, for the internal shape, for example, if I got a functional groove, then my third digit is going to be 3. Or if I have got a thread as an internal shape, then my third digit is going to be 2. And for digit 4, it is going to be whether I need a surface machining or not. Digit 5 about the auxiliary holes and the gear teeth which is required for that particular component. Having understood these things, now you will be able to write a code for the given structure. Here you stop, refer the Opitz system and try to write a code for the shown example. Pause here, write the code. And here this is going to be the code which you have generated. And here it is going to be a self-explanatory one. Hope you understood the concept of group technology and thank you.